Hi, myself Siddhesh Boricha. I'm going to present my internship project, that is IoT-based smart home automation. I have done my internship at Emertxe. So first, I will explain what I have learned during the internship, and then I will present my project. So what I have learned during the internship. C programming. C programming is a general purpose programming language developed in the early 1970s by Danish Ritchie as a part of development of the Unix operating system. C is one of the most popular programming languages in use today, as it is used in IoT embedded systems. It is widely used in embedded systems because of its efficiency, flexibility, and provide direct access to memory and other resources, allowing developers to write more efficient code. It is a pre-formatted language and not a strongly typed language. Library facilities plays an important role. Keywords. Keywords are basically predefined reserved words used in programming that have special meaning to the compiler. Typical C code content. So this is the format to write C code. First is documentation, writing some info about the code, preprocessor statements, uh, preprocess directives, that is hash include uh, stdio.h, then global declaration like declaring some variables, then the main code, local declaration, program statements, then functions, etc. Function body. Data types. Data types is a collection of data with values having fixed values, meaning, and all of its characteristics. Each variable in C has an associate data type. So there are four data: char, int, float, and double float. Conditional construct or statements. So conditional statement in programming language is basically statement that checks for the Boolean condition, that is true or false, or in zeros or one. In single iteration, if and its family switch cases. So in switch cases, there is a list of case which can be used in place of if else if. In multiple iteration, while, do while, and for. So while loop executes statements until the specified Boolean expression evaluate to false. Same go for do while. Now for false, there are three sections: index declaration, condition, updated section. So in each for loops iteration, the index is updated, like incremented, decremented, by updating section and checked with the condition. If the condition is matched, it continues execution until a specified Boolean expression evaluates to false. Operators. Operators are the symbols that perform specific mathematical and logical operation on operands. So there are seven types of operators. First, arithmetic. Arithmetic does some mathematical operations on operands like addition, subtraction, multiplication, division, and modulus. Logical combine two operands like logical not, logical and, logical or relational compared to operands like less than, greater than equal to, less than equal to. Assignment assigns value to variable equal to bitwise. The operator works on bits and perform the bit by bit operation bitwise, bitwise and bitwise or bitwise nor XOR, complement, right shift, left shift. Language contains size of that computes the size of the operand. Ternary, it can be used for decision making in place of longer if and else conditional statements. Array. An array is a collection of data of same data types. Addresses are sequential. First element with lowest address and the last element with highest address. Pointer. Pointer is a variable that stores the memory address of another variable as its value. Functions. Function is a block of code which only runs when it is called. Like function declaration declares globally function. Function called function anywhere. Function definition actual statement which are to be executed. So there are two parameter passing types: pass by value, pass by reference. While calling a function, we pass values of variables to it. Values of each variable in calling function is copied into corresponding dummy variable passed by reference. While calling a function, instead of passing the values of variable, we pass address of variables to it. Address of actual variable in the calling function are copied into the dummy variables. Memory segment. So in this the memory segment divided into four blocks: text segment, data segment, heap, and stack. So in text segment, it also referred as code segment. It is read-only section and size is fixed. Data segment, initialize. The initialized part is the data segment and uninitialized part is BSS block started by symbol. Heap is the dynamic memory allocation take place. Stack, it follows the uh, LIFO, that is last in first out structure and grow opposite to heap. Embedded system, any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Examples of embedded system: digital camera, industrial robots, gaming consoles, photocopies, smartwatch, washing machine, etc. Embedded system categories. First is standalone. It is independent system which can work by themselves. They don't depend on host system. It takes input in digital or analog form and provides the output. Second, real time. Strictly time specific, provide output in particular time interval and provide a quick response in critical situations. Network, connected to a network which may be wired or wireless, provide output to the attached device. They communicate with embedded web server through network. Next, mobile, small and easy to use, requires less resource, and they are the most preferred embedded systems. So this is the embedded systems component. In the middle, uh, that is my there are processors and microcontrollers. So the starting point is where the sensor the sends the data from the environment, and that sense data will be digital or in analog form. If the data is in analog form, it will be passed to ADC. ADC is analog digital converter. From that, it will be uh, it will go to controller, and actuators are, so now the sensor has collected data. Now it has to perform some action. So actuators are the one which performs action, and to perform action it needs digital data. So DAC, that is digital to analog converter. So it will convert into analog data, and actuators will perform the action on the environment. Memory is the place where the sensor data is stored. Uh, the next is human interface. Human interface is where like data is displayed or notification, some applications. Next is ASIC FPGA. ASIC is an application specific integrated circuit. It is designed for special app. Next is diagnostic port. It is used to monitor whole systems. Next is auxiliary system, power and cooling. Power system is where it will power the whole system, and cooling is to the cool the system, like sometimes heat up. So this is whole hardware part, and software is to program the hardware. Next is IoT. IoT is a network of physical devices connected to the internet, which enables them to collect and exchange data. This device can include vehicles, home appliances, medical devices, and more, and often features embedded sensors, software, and network connectivity to enable them to communicate and interact with other machines, objects, and people. So there are some challenges and what the IoT has solution to. So for addressing, so they have used public and subscribe protocols to scale, like sometimes the data has more. So to scale they have used cloud server. Then connectivity, so how to connect multiple servers, they have using queues format. Then data volume, as the data volume is high, so they have used cloud storage. Device size, like they have a solution of AMQP and MQTT. IoT reference architecture. So this is divided in three parts: device connectivity, data processing and analytics, and presentation. Device connectivity is where the data or the origin is from. So this IP cap- so one so in this there are two types. The one device which is capable IP capable means they can be connected to internet through Ethernet or Wi-Fi, and they perform bi-directional connection between them. And next are the which are not IP capable device, but they can be connected through a gateway. So the which are not IP capable device, they can be connected to the gateway, and gateway will be connected to the cloud gateway. Cloud gateway is a place where different format of data which are connected by devices are, are filtered to one format, and then they are passed to data processing and analytics part, which is IoT solution backend, where data is analyzed. And next is presentation, where presentation and business connectivity takes place. In this example, mobile application will present the data. So project part, project requirement. So we have used Arduino IDE to execute our code. Next is Pixim Lab. We, this is where we will perform our project. Next is Blink app, where we'll uh, build our application and displays the data, present our data. Then component, Arduino Uno, LED, LDR, LCD, I2C 16 into 2, temperature system, Ethernet SID, and serial time. So let me explain you about the project flow diagram. So first, the Arduino, uh, and its various components will sense data from the home, and that data will be passed on to Arduino, and that Arduino will be connected to the Ethernet shield, and Ethernet shield will pass data to the cloud server, Blink cloud server, and Blink's cloud server will pass the data to the Blink mobile app. The Blink mobile app is a place where we represent our data, visualize the data, and Blink mobile app will pass the data to home. Like we can see the data or some notifications about the home. So our component is Arduino Uno. Uh, Arduino Uno. There are total 13 GPIO pins, so, and analog 5 and 6 analog pins, and TX RX for serial communication. It is Atmega 328P microcontroller. That's serial time. We will connect Arduino and single time with serial communication. Next is LCD I2C 16 into 2. 16 into 2, basically there are 16 columns and 2 rows to display our data in this LCD. Next is Ethernet shield. Ethernet shield is basically a Wi-Fi module which will pass data to the Blink cloud server. Temperature system. It contains heater, cooler, and temperature system. In temperature system, will get temperature sensor data and heater cooling system and cooler 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 control system and control system data. Next is LDR, that is light dependent resistor. It is a type of resistor that works on photoconductivity, that is resistance changes according to the intensity of light. This will this component will be using garden light control. As sun rises, uh, the intensity will be high, and as sun sets, the intensity will be low. LED, light emitting diode, is a semiconductor device that emits light when current flows through it, and this is our blink app. Will display or present our data in this. So now let me show you my project. So I have loaded my bootloader file. Spec. This is LED, LDR, temperature, Ethernet shield, LCD. Let me connect my blink app to it. So this is my blink app application and the spare part and Arduino. So first let me uh, show you serial remote tank data. Let me connect it to my com. So as you can see, it start filling the tank. In this, the tank limit is 3000, and the data is also displayed, the water volume. So as it reaches to the 3000 limit, the date the notification to the home will be displayed. Water level is full, turning off the inlet valve. So let me on the outlet valve. So now the tank volume is decreasing. So as it reaches below 2000, the day notification displays water volume is less than 2000, turning on the inlet valve. So inlet valve is on. Let me off the outlet valve. So now the water volume is increased. And again the notification will display water level is full, turning off the inlet valve. So this was about the serial remote tank. Let me explain you about the LDR. So as I decrease, as I come, the light is off, and as I do, the light is on. Next, let me explain about the temperature system. So in this, now the temperature is 27. So let me on the heater. So as you can see, heater is on and heater on is display. And there is a condition where here, where when temperature rises above 35, the heater is automatically off. So let me on the cooler. As you can see, cooler system is on and temperature reaches to 27 again, and the notification is also display like temperature is about 35 degree, turning off the heater. Let me again on the heater. Again temperature is about 35 degree, turning off the heater. So this is the project. So let me explain you code. This is main.h, and in, in this I have defined virtual pin. These are connected to the Blink app like V1, V0, V2. Next LDR code. In this, the data like analog data is read, and we have to convert it into digital. So this reads the LDR value and then reverse map from 0 to 1023 to 25520, and the write and then write values to the LED. LDR sensor is connected to the analog 1 pin and garden light, and then is connected to the pin 3 GPIO pin 3 of Arduino. Next, the serial tank code. So in this serial tank code, first we need to read the volume of water tank and return it. The first serial dot write volume, sending command to request volume of water, then wait for the serial data, then read the higher bit and the lower bit. Then the, the inlet and outlet to enable and disable part. So sequence to enable the inlet valve and send pin number and send enable command. Then disable inlet, sequence to disable the inlet, send pin number and send disable command. Enable outlet, sequence to enable the inlet valve, send pin number and send enable command. Disable outlet, sequence to disable the inlet valve, send pin number, send disable command. Next is temperature system code. So in this, temperature analog output voltage from temperature sensor and converted into degrees Celsius, and the cooler and heater digital data. The temperature sensor is connected to A0, analog pin 0 of Arduino, and heater GPIO 5, a pin of Arduino, and cooler GPIO 4 pin of Arduino. So let me explain you the whole code. So this is about the cooler and heater blink, right? So the when the cooler is on the mobile application, then turn on the cooler, and to turn off and off heater base virtual pin value. Void loop. So in void loop, all the